those general method boxes, 3 of them actually, very close to the method box we have already presented. So overview, the overall step-by-step when we do this hypothesis testing thing that we have now been taught. Well, we formulate the hypothesis, the null and the alternative. We choose the level of significance. Sometimes the world has chosen it for us. We calculate now. So that is sort of setting the situation, right? Then we do the calculation, which is we compute a test statistic that measures the difference between the null and the data, right? That's what is being done. Then we do either of 2 things. Either we compare it with the critical value and make a decision, yes or no, reject or accept. Or, similarly, we find the p-value and then compare with the alpha and then make the decision. And then we could, if we want, be slightly intelligent also on the size of the p-value, sort of distinguishing a little bit how small it is. Only in the small area we should do like that. Here are the method boxes. Let's see. They come 3 almost identical method boxes, right? The 2-sided alternative version, that's the one I started with. The 1-sided less and the 1-sided greater. So it's almost the same thing, but it depends on this alternative thing, whether when we find the p-value, whether it should be computed in sort of using both tails or just one tail right to me and one tail left to me, opposite for you. Let's look at it. So this is just a repeat, almost the first thing here. Now we could call it, to emphasize what we just did, when there are no sort of one-sided settings, we call it the non-directional or 2-sided situation. We compute the t as I've shown you. We find the p-value when the alternative is 2-sided, like before, and then we conclude everything like before. So that's a copy of what I just exemplified to you. If it is a one-sided case, the p-value is only a one-sided probability. Now it's only one tail, either to the left or to the right. If I'm a PC screen example, if I'm going to prove that it's above, if I'm the outsider testing the company's conjecture, I should prove with no doubt that I'm above. I should only, as an alternative, compute probabilities above, because probabilities of something happening in the low end is not critical for my hypothesis, in a way. That's a way to say it. Otherwise, it's the same thing. However, when we find the p-value, we still compare it with alpha. For the critical value, this is different. For the critical value, it's not it's only T alpha. So now I have not alpha half, but alpha here, right? I should find the critical value with 5% if that's the level I'm using, not the 2.5% anymore. And vice versa, or oppositely so, if it's the other alternative to the right. So this is a little detail, this 2-sided, one-tailed thing that sometimes makes us a bit confused here. The general rule is, if there is nothing that makes me think about being one-sided, then you should be 2-sided, non-directional. That's also as the scientific argument, actually. If there is nothing in favor of not being 2-sided, you should be 2-sided, right? It could go both ways. So that is always the starting point. And if nothing else, that's what you do. And you will see R, that's also what R is doing if we tell it nothing else. Let's try this PC screen example. What if we take the sort of external point of view, that we're an external group of consumers that would like to prove the company wrong in their conjecture. So I'd like to prove this null wrong by having this one-sided alternative. I take my data. My data is actually larger than 83. Had it not been, I would have been finished. It's clear in a one-sided case, if I saw and not saw something above 83, I couldn't prove anything to be above 83. That would be silly. So I'm just finished then. Now I have to evaluate how likely is it to go as high as 85.7 with a standard deviation of this. I transform that to the t-statistic, to the t-ops, to the observed t-statistic by taking the data, comparing with the null hypothesis, plugging in the standard deviation and the n in this case, finding a t-ops of 1.97, finding the one-sided p-value. What is the chance of going above 1.97 in the t distribution with how many degrees of freedom? 11 degrees of freedom, right? That is 3.7%. So I didn't say, but if I use the default level of alpha, what is the conclusion? We reject. We have proved the company wrong, right? This could be done in R, like this. Remember when I didn't do anything? When I didn't write anything but x, if I now run very fast back to my slide showing you what happened, maybe not a good idea, but now I did it. What happened in R when I just plugged in something and I didn't tell R anything about what it should do? I just plugged in the x. R did two default choices for me here. It chose the alpha for the confidence interval, and it also chose the alternative hypothesis for me, right? And it actually told me what it chose. Nice of R. Because it told me that this is my alternative. Yeah, two choices actually. It made a two-sided choice, and it decided to compare with 0, even though I didn't tell it anything. That's the default choice by R. That wouldn't cover all our situations. So I'm running back to my example here, where my way to use it here would be to say, hey, don't test the 0, but test the 83. And hey, don't test it two-sided, but test it one-sided alternative greater. The other version is called less. I use those words in my method boxes also to make the link explicitly to the R options here. Then it tells me, like this, what I've just found from before, right? And it also informs me about the alternative that it used, this alternative. It informs me that that is what it has used, because I asked it to, of course, but it tells me again back. So that was hypothesis testing, one-sided,